Welcome, everybody. This is Access Lunchtime. I am Maria Barnes and the chapter president of Access Lunchtime. Today, we are going to do a presentation, and I'm going to be joined by experts Neil Sargent and Leo, the theDBguy. You may know him as. Today's topics is going to be how to use collections and dictionaries to work with JSON in Access. And technically, you can use this in any kind of VBA, not just Access, but the demos here today will be using Access. For starters, let's identify first a dictionary and what it is, and then next, a collection. In order to look at the dictionary, it does use the Microsoft Scripting Runtime, which is a reference that you will need to add to your VBA project. So here is the link to a nice article on using the dictionary class in VBA. That's a good reference. But if you would, the dictionary is simply a grouping of keys and items. And there's various methods you can use in a dictionary. There's an add method that you can see in my example here. I set up a new dictionary, and again, I did have to have a reference in my code to the Microsoft Scripting Runtime before I could compile this. I set my body equals to a new dictionary, and then I did a body add, and then I put the key name and then the item name. And you can add different types of keys and items. So like, for example, this first add, this is a string. The second add is technically a string, but it's really a website link. And then the third add is a number. And then there's other methods that you can use for a dictionary. You can use the exist method, which lets you know whether a key already exists in your dictionary so that you don't duplicate keys. You can use the items and the keys methods to get to the various items and keys in your dictionary. You can use remove to remove a specific key and its item pair, and then you could clear it by a RemoveAll function. And one of the coolest things is that dictionaries can be nested. So like you see in the second part of this example, I set up another dictionary location, set it to a new dictionary. Then I added a couple key item pairs to it. One was an address and one was a city. So that itself is a dictionary. And then back to my original body dictionary, you can add with a key of location, the location dictionary. So in this case, what you would see is a dictionary within a dictionary. And in order to illustrate that, we're going to post after this a link to a sample file here. The sample that I have, there's a module, Collections and Dictionaries. The first sample here, routine, does exactly what the sample code on the PowerPoint did. So you could go in and run this code, and you would have these items and then this fourth item, location, which is a nested dictionary in the body. And the reason I set this dim body as dictionary up here at the top is so that all these subroutines could use it, because as we'll see in the next bit, in test collections, we use the same body and we add a collection to our dictionary as well. So a collection is actually part of the VBA language itself. And I'm going to put another link here to a good reference in the VBA language. about collection objects. But a collection is simply a ordered set of items that can be referred to as a unit. Again, it's part of VBA. You can think of it like an array, but it can be accessed either via an index or a key. And similar to dictionaries, it has various methods. It again has an add, it has an item, it has a remove, and it has a count. And a count will give you the number of items. And think of it as the items being the objects in the array. So in this example, we've got a new collection. We call it employees. And we're going to nest a dictionary inside of a collection. So remember I said that a dictionary can be nested inside of a dictionary. You can also nest a collection inside of a dictionary, and you can nest a dictionary inside of a collection. That fact, that nesting both directions, is what gives dictionaries and collections the power to end up making a JSON object. So we'll show you that a little bit later. But in this example, I set up both a collection, which is called employees, and a dictionary, which is called employee, and then set the employee equals to a new dictionary and add two keys and values to the dictionary, a first name and a last name. And then I take that collection and I add the employee dictionary to it. That's in this line right here. And then I do the same thing and I add a second employee, and then I add that employee. So that will then become the second item in the collection. And then at the very end, I go back to my body and I add employees, which is the collection here, as an item. So yes, Adrian, collection is a member class of the VBA library. So we'll be able to see it directly and compile. You could without any additional references, right? You don't have to have a reference to that. That's standard. You can just compile that code. And that looks like this. And I've got in our sample here a test collections routine where I do exactly what we did. It's a little bit prettier format in the routine. I kind of crammed everything into the slide. Again, we take the first employee with the dictionary, then we take the second employee, we add each of them to the collection, and then add the whole thing at the end here. Okay, now let's step back and talk a little bit about what is JSON. And I will put in the chat this link that I have listed for you at the bottom. JSON stands for JavaScript Object Notation. And it's basically a lightweight format for storing and transporting data. People also use XML for storing and transporting, but XML is more complicated and more extensible than JSON. JSON's a bit simpler to use. It's often used in web communications, and the JSON itself ends up representing objects or arrays. And if it's in what you call a pretty format, which we're going to talk about a little bit later, it's pretty easy for humans to read. And I think the next slide will show you a bit more about what the JSON for the dictionaries and collections we've looked at so far looks like. And we're going to talk a little bit about the syntax of JSON. JSON syntax has some rules. The data is in name or key value pairs, and the data is separated by commas. So you see that the first item here, this is what JSON would look like in pretty format, which is kind of with indenting and line feeds and stuff like that. When you communicate JSON to the web, usually it's all in one mushed up string without any line feeds or spacing like we have here underneath location. that makes it easier to read, but that's usually not part of the string that you pass back and forth to the web. It's usually in a kind of a straight format or a non-pretty format. So the data is separated by comments. So you see you have here the name and the value, and then you're going to go on to the next item. And in order to go on to the next item, you have then a comma that separates the next item, and then another comma, and then you can nest items. So here we have another bracket that indicates it's an object. So curly braces indicate that there's an object inside. And then in this case with employees, it has square brackets surrounding the curly bracketed lines. So the square brackets indicate that it's an array or a collection. And in general, the arrays and the collections, the items within them are of the same common kind of structure. So in this example, we have a dictionary. It's got 5 items: company name, website, annual turnover, location, and employees. The employees object is a collection, and it is an array of 2 employee objects or dictionaries. And the location is also a subdictionary because it's got multiple items in it. It's got the squirrely brackets inside of it. Questions so far about what we've talked about?
Maria, I'm looking at this, what you've just talked about, the notation. You defined the location originally as an object, but then you came back later and said it might be a collection. So how do you determine whether something is an object, a collection, an array, or do you not? Does the squiggly bracket say, well, this is an object of some sort, which could be a collection or a what's the name, and the array is reserved for the square brackets? Am I close?
I'm not sure I understood you correctly, but let me...
Shall I answer that?
You certainly can. Yeah. This Neil, right?
Yes.
Okay.
The squiggly brackets denote an object, a JSON object, which maps to a dictionary.
Must it map to a dictionary, or is that sometimes it might?
Sorry, maps to a dictionary in the VBA conversions that we're going to show you later.
But I'm interested in
just in your pure JSON. There's no such thing as a dictionary. It's an object, and it's denoted by a squiggly brackets.
Right. Thank you. That makes more sense. What about
the collection? Again, it's not a collection. They're actually handled as an array in JSON, and they're denoted by the square brackets. So if you think in terms of objects and arrays rather than dictionaries and collections, when you're thinking about pure JSON and looking at the syntax, in this example, you can see that location is an object and that employees is an array, and the items within that array are each object. So it's an array of objects.
Right. So you've got square brackets. You mentioned a second ago, you were saying it's an array or a collection. Surely a collection.
Sorry. An array and a collection. There's no such thing as a collection. In JSON, they're called objects and arrays. And in the code that we're using, we implement the using dictionaries and collections.
So we implement the objects as dictionaries and the arrays as collections. So maybe the fact that I have the word collections on here, on this particular slide, is confusing. Is that valid?
It's not so much that, no, because from a VBA perspective, collection, dictionary, not an array, but all the others would be treated as objects. And here we're treating, what was it you said, Neil, this square bracket, it was an array represented as a dictionary?
Yeah, I think what we've muddled up here is that the JSON concepts are limited to just objects or arrays. End of story. And we implement the objects as dictionaries in VBA, and we implement the arrays as collections. We don't use arrays, we use collections rather than arrays as a means of implementing the JSON arrays.
it actually maps directly on, an array in JSON maps directly onto a
collection in VBA, yes.
VBA.
Correct.
There is no arrays.
We don't use the arrays within
Can't
the
work in the same way as this.
Use collections instead of arrays. Yeah.
So that's a valid point. Thank you for asking those questions. To create JSON, we're going to use collections, which are part of VBA naturally, and we're going to use dictionaries, which are part of Microsoft Scripting Runtime, which is a DLL that you can bring in. And then we're going to talk here about how to automatically convert and parse JSON using two different tools. And one of them is by Tim Hall, and it is a VBA JSON. Now, I'm going to say that the same routines that are in this particular tool are also in his VBA web tool, but we chose to use the JSON tool because it's simpler and only has the one module in it and not a lot of extraneous stuff. So, but if you're already using the VBA web tool by Tim Hall, you can also get these same tools from that. And then there's another one that is the JSON which is an online web one. And I'm going to demo that in just a minute here. Before I do that, let me just talk a little bit about Tim Hall's tool and how you would go about downloading that. So that is in GitHub. And so you would go to that, and then you would go to code, and you would download the zip. And that zip file will come with inside it a BAS file. And then you would want to go to your modules in your code, and you would want to import file, and you import that BAS file, and it will come in here as a JSON converter. So this is what it looks like. And it will have some tools that we're going to reference here shortly in prettifying JSON. But before we do that, let me go ahead and run these two routines. When I run those, start with my immediate window here to run them. All right, first I'm going to run text dictionary. So let's just look at what body looks like after that, because what this did is it took the dictionary, it added in 3 items, and then it made a sub-dictionary essentially, and it added a couple items to that, and then it added that dictionary to the main dictionary. So I believe that if we take a look at the locals window, I'll start here. Okay, so in here we have our body, and that has these items: company name, website, annual turnover, and location, right? This one actually has a sub item, and then we've got these, and then we've got, let this run to the end. So then we have our 5th one, employees. And we could actually drill down and see those. Another thing we can do is then now how do I get the whole string of the body? Can you help me out here, Neil? Can I get it from here to go over and take
you'll have to convert it into JSON at the moment.
I'll have to convert it first? Okay. All right, so I'm going to go to the VBA JSON library, and I'm going to go to the routine that is convert to JSON. I'm going to convert to JSON, and I'm just going to do convert to JSON, and I'm going to pass it body. And that should give me this string, which it's not really easy to read, right? But if I go back to this tool, JSON Parser, you can paste that in here, and it's a little bit more readable here, but you can also use this compact JSON and remove, oh wait, that's compact. Is it the other one? This one? Here we go. The format.
You need to delete that.
Oh, the extra.
You didn't
yep, thank you.
clear the braces, yeah.
Should have overwritten today. There we go. All right, and then you make it pretty like this, and then it's much more readable. And here you see that, yes, indeed, we do have a comma after the Island View Drive, which is the address 1. And I believe the other missing thing in my example was the semicolon. So yeah, that's what I want to show. Is there anything else you want, either of you, Neil or Leo, want to say about the JSONParser.org?
Yeah, sure. This is Leo. Okay, if you click on JSON Parser button in the middle, that's like your locals window in VBA where you can drill down into each
So here you
object.
could see the location and the subs under there. Like that. Yeah, you're right. This is really nice. And it's very helpful when you're programming and working with like web APIs, for example. You're going to pass JSON somewhere and you want to make sure it's right. Okay, because if it's not correct, if it's not formatted right, if you have website 2 and it's supposed to be website, or if you put the address into the website or whatever, you're not going to get the right result. So it's very helpful to use during your debugging. Somebody says you can drop this into your browser to get similar. So you're saying that I could take the option here and I could paste that into my browser like this, and it's going to give me pretty? No. What did you mean by that comment? These are the two main functions that you can use from Tim Hall's VBA JSON library to look at what you've got. Parse JSON turns a JSON string into a VBA object. You can read what comes back from a web API call, for example, and put it into a VBA variable, and then you can work with it. And Neil is going to talk a little bit about how you go and use type name to determine what types of objects you have in there, whether or not you're going to transfer it to a dictionary or collection. And then the convert to JSON object also turns an object back into a JSON string. So I used it to convert my body object, which was a dictionary, into a JSON string. And then there's even a parameter that I could have used, which I didn't, that would give a prettier version directly. Oh, if you save the text into a text file and open in your browser. Okay, that's interesting, but that's another way to do that. Good to know, yes. So Neil, I think we're going to have you take it from here, correct? I'm going to stop sharing and you can show a little bit about the routines that you added to this database that make use of those functions and how you can drill down into it a little bit better inside of VBA.
Okay, thank you, Maria. When we previously looked at the APIs and we saw the JSON coming back, some of us have seen examples on the web of how to then read that JSON. And in order to really understand how to read the JSON coming back, we need to understand how it's being converted into VBA variables for us to work with. So Maria has shown us how to actually create the dictionary item in the first place. And the job of the parse JSON function is to convert that object that we've created in VBA into a JSON string that we can pass up to our web API. So the example I'm going to do is, I'll just step in to the right function. I'm going to step through the function, and as we go through, we'll see what happens to the data variables as we convert it. We convert the JSON string that has come back from the API, and we're converting it into objects that we can use in VBA. For this example, I'm using the Google APIs, which you may have seen before. They're free APIs which are available from Google, and they've got one in here called the Books API, which you can use for free. You don't have to authenticate and so on. And in the Books API, we can get a list of books which are available on the Google API site. I think the purpose is to be able to read it and basically for Google to be able to sell them to you, I think is the essence of it. But browsing around and looking at all the book information is a free API. So when we call the API with the list function, it tells us here what we have to put into our API, and it tells us what's going to come back is a JSON string, which will be a list of books. That's all we need to know at this level. We've seen how to do that in earlier presentations. So the JSON string that's going to be returned from the API, going back into here, I've just taken a copy of it and I've put it into this example table, and the string we're going to look at is this one, which I've copied having read it from the Google API. So I'm going to read it into a string variable simply by looking up from my table, and I'll print it out, and as you can see it's pretty unreadable, and it's also quite a big string. It's about 30,000 bytes, and it's a list of 10 books. So in order to convert it into an object for us to work with, we use the parse JSON function, which simply takes a string and returns an object. The first thing that we need to know is what type of object has it returned when we pass the JSON. Now, in this case, it's telling us that the type of object is a dictionary. And so because it's a dictionary, I'm going to actually put it into a dictionary object, which I've defined here. And that will allow us to look at it with IntelliSense and debugging, rather than an object where it doesn't really know what it's describing. We'll be able to look at the dictionary as a dictionary. We've been told by the JSON parser that it's returned a dictionary type, so we can put it into a dictionary variable. So if we open our window, we can actually see that dictionary now. And the dictionary has returned a total of 3 items, and the keys to the dictionary are kind, total items, and items. Now we can explore what's come back from the thing, but really when we're working with APIs, we ought to know what's coming back from the API. And in fact, that's what the documentation of the API is telling us, that if you call this method, I'm going to return an object with the curly braces with 3 items in it, one called kind with a string called book volumes, another one which is a list of items, and a total of how many items are in the search results that we've done. And it does actually warn us down here that that number may be greater than the number of returned values in our list because it's paginated, because you don't want to get all 2,000 items come back as a single string. It will come back in pages. So we can look at that dictionary item, we can print out the count, and it shows us the count is 3, and we can loop through each of the keys and get a list of those. So we can see from the immediate window up here, we've got our kind, our total items, and our items. Now we could actually print out what the values of those item value pairs are, but we've got to be careful here because the data types for the items that it's returning can actually be complex data types. As we've seen in Maria's presentation, you can nest dictionaries, you can have collections, and she's got an example with a collection of dictionaries in hers, where she's got an employee dictionary item, a collection of them is her list of employees, and then that is included in the overall dictionary saying, this is my list of employees in the company. And if we try and debug print an object or a collection, then we're going to get a runtime error. So before we do anything with the data, we need to know the data types, which in this case, Google has very nicely told us, but in some more sloppy APIs, that's not always the case. So here, what we'll do is we'll first of all go through and see what the types of the three items are. And it's telling us that kind is a string, total items is a double, and items is a collection. Now, something to note here is that if we go back and look at our definition of the API, total items should be an integer. And yet our code here has returned a double. Now imagine what the code has had to do. It's seen a number. It's just seen the number of results, which is 1,000 something. And it doesn't know whether that number is a big number, a little number. It doesn't know whether it's got fractional parts. So the data has come back as a double, as a sort of like catch-all. It's a universal number which will catch almost every number that is likely to be thrown at it. And that's why it's returning doubles. In your real code, you might actually want to then return the value and put it into an integer variable because you know it's meant to be an integer. Or in this case, that's probably a long because that's what an integer means to the rest of the world. So we've gone through and we've looked at our types by going through each of the keys in the dictionary. We've got keys called item, total items, and we're using the dictionary item method with the key that's been returned to return the actual item, and then we've checked its type name with the type name function. So we could do that another way. We could actually just go through our list of items in the dictionary, because the dictionary has an items method which returns each of the items in the dictionary. So if we run through that, it's an alternative way of doing exactly the same thing. Okay, but this time we haven't had to even bother with the keys. We just know there's three items. So it's an alternative method for us to actually list our items. There's another way. As we said, the items are actually an array of items. So we can go through the indexes of the array and we can get the list of items that way by treating it as an array in the traditional sense of going through 0 to n-1 items. Now, irrespective of whether you're dealing with arrays as 0-based or 1-based, the scripting dictionary will always return a 0-based array. It's not dependent upon your setting of option base. So if we run to there, we can see it again, run to cursor, and we can see this time that we've got, I don't know what's causing that empty to appear on there. But basically it's gone through each of the three items in our array and listed each array item by index. So our dictionary is allowing us to actually look at the value of a given key. It's allowing us to look at a list of keys as an array, a list of items as an array, not caring about the keys, or actually just go through the items index one at a time. So having gone through our dictionary and worked out which types, we can then decide what to do with each of the data types. And in this case, what we're saying is, we know that in this JSON system, the only objects that are going to come back are going to be either dictionaries or collections. Dictionaries means that we've found a nested dictionary item, or collections mean that we found an array of items inside the JSON. So if it's not an object, then we're safe to print it. So we can just print out what the value is. So the first one is type string, so we can print out that it's book volumes. We go round second item. This time it's type double, so we can print the number. Next time we come round, this time it's a collection because we're now on our third item, which is our list of items. Okay, now our list of items, we can't just print list of items. If I try and do that, I'll get a runtime error. If I say, what is var item? Runtime error, you can't do that because the immediate window can't deal with it because it's an object. What do you mean print an object? I can't do that. I can only do things with objects. I can't print them. They're too complex. But what we can do, because we know it's a collection, is we know that a collection has a count. We can say, right, how many things have you got in your collection? And also, a collection has to be a collection of like-typed objects. So we can look at the first item, look at its type, and so we know it's a collection and what type it is. So in this case, we can actually print out it's a collection and there are 10 items of type dictionary. So it's a collection of 10 dictionaries. So this is telling us that the item list is telling us how many items and the type. So if you imagine, it's fairly similar to what we were actually looking at here on the JSON parser. It's telling us that we've got kind, book volumes, total items, and then 10 items, and each one is a dictionary. Can you see the squiggly bracket? And these are the 10 dictionaries that are coming back. So we've managed to decode our JSON into a set of dictionaries, collections, or normal VBA variables. And that's the purpose of parse JSON. It takes the JSON string and puts the data being represented by the JSON into our VBA variables. Are there any questions on that parsing before I move on to the conversion?
It might just be a comment. You said you check the first element, var item 1. Surely var item 1 is the second element?
No, because it's a collection and collections are one-based, aren't they?
Well, not according to that thing that you showed us at the same time, because it listed it on the web page and it went from 0 to 9. When you showed the same data on your web layout, the first item was 0 and the next one was 1, etc., etc.
That's how the tool on parser.org displayed it.
Right.
If we look at type name var item 1,
Okay.
if we put a naught in there, yeah, we'll get a subscript out of range. It's because what we're looking at here is not the original array. It's not the naught-based array. We've put it into our collection now, and so it's a VBA collection. VBA collections are always one-based.
Are they? I've not used them very much, to be fair.
Yes, they are.
They're all one-based. Oh,
yeah,
okay.
Very confusing, but they are. Are they one-based or option-based? I think they're one-based.
Well, I would imagine they're one-based because I doubt you've got option-based set to 1, have you?
No, I haven't. So yeah, so if we go, so they are actually, if we go to var item 9 and var item 10,
yeah,
that's working, and 11 will be out of range again. So yeah, they're definitely 1 to 10.
So that's the difference between collections and arrays. Good to point out.
Yeah.
I kind of missed that.
The other thing is the other thing about collections that is not very well. I for years I thought collections had to be a collection of objects because that's how we use them in Access. We have collections of controls, we have collections of forms, we have collections of all sorts of different objects. But actually, it can be a collection of any data type. You have a collection of strings, a collection of integers. You can have a collection of any data type you like. In this case, we've got collections of dictionaries going on. So long as every element has the same data type, in that way it's similar to an array because it's a repeated item of the same data type. And that's where it's very different to dictionaries because every different item in a dictionary can be a different data type, as we've seen in our example. We've got item value pairs where we've got a kind of a string, a total items of a long, which we interpret as a double, and items, which is a collection. So the list of different items in a dictionary all have potentially different data types, whereas in a collection they're always the same.
It's interesting. I find it very interesting that an array has elements but nothing to indicate, apart from the index, nothing else to indicate which is which. Whereas a collection is like an array, but you can give it a name. Each element has a name as well as an index.
Think of it as an indexed array.
A dictionary has everything that a collection has, but it also has that variability of its data type.
That's correct.
It's interesting extension. One is an extension on the other on extension of the other, which is interesting.
Yeah. The link that Maria has already put in the chat, the article on dictionaries gives a really, really good explanation of the differences between dictionaries and collections, the pros and cons. It's a really good article. It was actually when I first got faced with understanding JSON that I was forced into understanding dictionaries. It's like a revelation. They are superb.
Mm.
So we've done the parsing of JSON. Now we're going to look at how we would convert JSON. Now, Maria has already shown us the conversion JSON from the JSON that she created. So I'll just whiz through this, showing you basically the same thing. She created it using the test dictionaries and test collections, creating a body. So I've used her functions above to fill body with a dictionary, and here's the dictionary that she created with her company name, website, annual turnover, location with its addresses, and the employees, which is a list of employees, first name, last name. So if we want to actually see that as a JSON string, we just use the convert to JSON function, and we get it as, sorry, let me just clear that immediate window and do that again so that it's a bit clearer. As we said before, this is what the web expects, just a long string. Don't waste time sending me spaces, because we just got to get it over the net as quickly as possible. And it's not very easy to use. And the important thing to understand is that this convert to JSON function has a built-in white space, which allows us to actually say, have it out with 2 spaces per tab and make it much more readable. That's very useful, because one of the things that we do when we're debugging our code is we want to look at our variables. And if we're constantly looking at variables, which are like this and hard to read, it's much easier if we convert them into a pretty format, which makes them human friendly. So what we can do when we want to prettify our string is we can actually do a trick. If our string is in an unmanageable state, I'll do the example again. In this case, what I'm going to do is I'm going to actually go and get one of those book examples. So I get the book example and print it in JSON, and oh my goodness, how am I meant to debug that? So the trick is we use the JSON conversion functions that we've got to first convert the JSON into an object. Now that object in this case will be a dictionary, but the JSON, if it'd been a bit of JSON rather than the whole JSON, it might have been a collection inside it, or it might have been just some name value pairs. So we converted it into an object, and then what we're saying is, well, now convert it back, but this time show it to me in pretty format. So what we've done is we've actually taken our code from a long unintelligible string, and we've quickly converted it into an object back into JSON and asked it to tab it out for us, which is going to help us when we're debugging our code. Now I did it as 2 stages there, but obviously all you have to do is convert it. First of all, parse it to turn it into an object, and then take the object and convert it into pretty JSON. And then, of course, if it's a really long string, then you saw how far I had to scroll back up to actually see what I want. Often we just want to know that we've got it right at the beginning. And what you can do here is just chop off the first 1,000 characters so we can see what we're doing in our window here. And it might be that if you've got some JSON which represents lots of records, you might just want to check that your structure's right. You just want the first few records, so you can play around with how many characters you want to display and just print a bit of your string in your debug statements. Any questions on that?
So just one clarification, we do have some questions here. And indeed, we did say something earlier. Usually when we're working with collections in JSON or parsing out JSON and putting things into collections, what we do get is items in a collection that are the same type. I'll revisit that question, but we're going to talk about collections and why technically they don't have to be the same types under a collection after you're done. Let's go ahead and finish what we're doing here.
Okay. The other thing that we wanted to demonstrate here was that it can be very confusing to any user of an API when, for example, you saw how much data came back when I just wanted to look at a particular book from the API, and it came back with all that information about who the publisher was, who the authors were, and so on. We came back with a long JSON string. Well, sometimes all you want to know is who wrote it. So you might go off the API, and the only thing you can get is all the information about the book, and you just want to extract that little bit about who the author was. So what we do when we get our data back is that if we go into our JSON here and we've got our objects and there's 10 items, and we look at the first item and the volume info, and there's the authors. So we have to go all the way down here to see that J.K. Rowling wrote that book. So if we want to turn that into our VBA variables that we spoke about, then we know that we first of all have to get our JSON dictionary, JSON turned into a dictionary to give us our object. Then we need to go to our list of items and get a collection of items. Then we have to go to the relevant item for the one we're looking at. And then we have to go to the dictionary, which is the volume info. And then we have to go to the authors. And if we did all that in code just to get one item out, it would be very, very difficult to work out. But what we can do, and I'm going to put the example here. I think we've got a tailwind. Yeah, I can actually put the code on the right. You can actually see the JSON for the book that we're looking at. And the thing that we're actually interested in is this J.K. Rowling was the author. So we've asked Google Books, this book called Harry Potter and the Sorcerer's Stone or whatever it is, who was the author. First thing we need to do is we'll go into our code, we'll read the text into our JSON string. So here's the JSON string. That's what's come back from the API, and we just want to extract this bit about who the author was. So the first thing that we can look at is we know that what's coming back is a data dictionary, and that it's got a kind, and it's got items, so we can look at these individual values for book volumes and 1136. And then we can see that there's an items list, and we can see it's a collection because it's an array. So it's got a count, and it's telling us there's 10 of them because they're coming back paginated 10 at a time. And then we can look at the kind variable. We can look at the ID of the book. This will be Google's actual ID of the book. So what we've done here is the first set of brackets is the items value. Then we've got a collection. So we're looking at the first member of the collection. And then we're looking at, within that collection, if we want to look at the self-link, we're looking at the self-link. So can you see that as we go through, we've got to go through now and get the volume info. So we go in another nesting level, and we can look at the title. And then we've got the authors. We're finally down to where we wanted to get to. It's telling us there's one author. So we look at the first author, and there it is. We found J.K. Rowling. So if all we want to do is extract from the JSON, the huge JSON string that's come back from the API, we just want to work out who the author is because that's all we asked in the first place, then we basically know that we have to go to the items collection, first elements, the volume info dictionary structure within it, or object within it, and then the authors collection. Sorry, no, the authors object, which is a collection of objects, an array of objects. Look at the first element, and we get the first element, which is J.K. Rowling. So sometimes we've seen this code, and it's a bit mind-blowing to see that, oh, I've got called this API, and what I've got to do to get my data out looks horribly complicated. But what it's done is, without having to create code to walk all the way through the dictionary, we've gone straight to the element that we want in the nested dictionary. If we look at the second example, down here, there's a book, Harry Potter and the Cursed Child. It's actually got 3 co-authors, J.K. Rowling and 2 others. Now this time it's the second element of what's come back. So all we're doing here is looking at the second element. It's telling us that it's 3 items and that the authors are J.K. Rowling, Jack Thorne and John Tiffany. So using this nested string method, we can actually extract individual items out of the huge JSON string that's coming back from our API. Okay?
Or like you would probably normally do, you would do some kind of loop and do a for each and then only extract the info you wanted, like just the author's info. You know?
Yeah, if you wanted a list of authors, all the
but
authors.
It would still be similar to this. You have to understand this.
Would I be right in thinking that this notation depends on the line near the top that says set OData equals parse JSON? So you're actually not referring to your JSON at this point. You're referring to the data, the object or set of objects that you've created using that line of code.
What we've done is we've taken the JSON, we've turned it into a single dictionary object, and that dictionary has got nested collections and objects. And what we're doing is walking down that nesting to find the individual items that we want.
I just want to mention that there are problems with interpreting JSON this way using the VBA JSON tool. For instance, there's a lack of support for nulls. It doesn't support multi-byte Unicode characters. Someone mentions that it handles dates differently. Yes, it returns dates as strings, not as dates. And so you would have to do some kind of conversion if you wanted to store it in a date. There are some problems and limitations, and I believe we're going to try to have a follow-up session in February for Access Lunchtime, going into more details about some of those and how people have gotten around that. Neil in particular has made some modifications to that tool in order to get things to work like he would like it to. So please look for that announcement coming out when we get that firmed up about our February follow-on topic to that. The links to those references that I already probably put in the chat, and this is contact info for the 3 of us. Besides that, I did want to follow up with that question. The collection object, this is the reference in Microsoft Learn. It's an ordered set of items that can be referred to as a unit, but the members of a collection don't have to share the same data type. In practice, in return JSON, they usually do, but they do not have to share the same data type. So, yeah, other questions? And again, you guys can come off mute. Just try not to all talk at once. There's not that many of us.
I don't think there are any questions. I could be proven wrong. I don't think there's any that haven't already been fairly fully answered. But if anyone feels that they have a question that they didn't get an answer to, tell me I'm wrong. I'm happy to be told I'm wrong.
That was my impression too, Adrian. But I know you stay on top of these things.
I just have one additional comment, or maybe it's a question. This presentation basically concentrated on using Tim Hall's VBA JSON library. And I'm sure you all are aware, but in case for those who are not, that's just one of the options. There are actually other ways of parsing a JSON and into VBA. For example, Jack Leach has published one that uses the JavaScript, I think, runtime. And there's another one on GitHub that's created by Eric Ubona, Eric with a K. That's the one I'm using. And of course, I think Colin created his own version as well. And whenever he decides to publish that on GitHub, maybe we'll have a fourth option. And I don't know if anybody else know of any other versions or options.
It might be good to go into a few of those if we have a chance in the February session to give some depth to it, because we probably can't spend an hour on what all the problems are, but I guess let's iron that out here because that would be interesting too.
Right.
I think,
Not
as
only
a follow-up.
not only the different problems and methods, but for example, the syntax that Neil presented on how to drill down to your JSON objects to find the author. The syntax for doing that for the other parsers are different.
Got it.
Oh, one additional thing to consider is speed. So when you use VBA, a JSON by Tim Hall to parse a JSON, depending on the size, it could take so much time. And then if we use JAX, could be faster or slower, and the others too. So that's the other consideration.
Yeah, I'd be very interested in knowing what some of the alternatives are and different methods that they use. That would be something to look at.
One thing we did intend to show is that JSON can be really big when you get it back. And if you just do a print in your immediate window, you can get just the last so many characters and it can be really difficult to read. So either going into some kind of Prettify tool that can handle that, or doing like a left 1,000 or a left 2,000 or whatever might get you. What you really want to see is, like, if you've got a big collection, an entire first element of the collection to get a feel for what it's like. And, maybe you're partway into your second collection. You don't need to see a whole bunch, but it's very helpful to have the stuff at the beginning to get you started and to get you down there. It's a lot less helpful to see the last part of JSON in the immediate window.
One of the things to bear in mind is that an API might have a fetch individual by ID type function available, or it might not. It might just do a list where meets criteria. So sometimes what will be coming back from the API will be a list of one item. So you end up still using a sort of a nested parentheses just to get the single item that you've got back from the potentially longer list of items. Does that make sense?
Not to me, sorry, Neil, but that's probably just me being tired.
Yeah, so I think what he means, maybe if I say it a different way, is, for example, with the books, right? If you got a list of all the books in the library, that's going to be huge and it's going to be hard to get to. If you filter it on lists with the title Harry Potter, it's going to be a much smaller list. So if you've got stuff that's so big to handle as return JSON, you should consider whether there are alternatives to grab more accurately what you want in a smaller.
I think the point I was trying to say was that an API might choose to give you two functions: get me a record by ID or get me a list of records. But some of them would say only provide the second of those. So you actually have to say, get me a list of records where the unique ID is this. And what you get is a list of one item, which is different to getting a single item. So what you'd end up with is a collection of books with only one element in that collection, one item. So you still have to actually look at it as if it was a list of items rather than an individual item.
Specifically addressing the Google Books API, there is an argument you can put in the query string to limit it to X number of returns, like the top 5 or the top 10 or the top 1.
Yeah, that's what I did to make these strings
Yeah.
manageable. That's how I got my 3-book listing out of it.
Yeah, and my experience has been if I don't get the book I'm looking for in the top 4 or 5, I'm probably not going to find it anyway.
The other thing that I found is when I was preparing this demonstration is that the list doesn't necessarily come back in any particular order.
Oh, no.
So in this case, there are, whatever it was, 1,000 Harry Potter books, or 1,000 odd Harry Potter books, but they didn't always, when you always got 10, but you didn't necessarily get the same 10, or you didn't get them in the same order. So I had to be careful for my demonstration to actually save a specific result and work with that rather than just rely on using the live API, because it would come back with a different list to the one I prepared for.
That's a little annoying.
Yeah. But it's a bit like it's true of SQL. You know, it's not order specific. It can come back in any order it feels like.
Just
Well, yes,
bucket of data.
but you can usually specify an order in that case. So.
Yes, and in fact you can, for example, this API, you can actually ask it to sort it, but only according to recently used, only a couple of criteria you can put on the sort on it.
Well, we were hoping that this presentation today helped clarify. I know that several of the topics we've been going over in Access Lunchtime this last 6 months have been about web APIs, about using or making JSON to send to web APIs or receive back and interpret. And some of those conversations have been a bit confusing, understandably, for some of you that haven't done a lot of this. And so today's presentation was to hopefully help clarify some of this stuff. And I'd like to say a special thank you both to Neil Sargent and Leo for your added expertise here today, and Neil, all the demos that you prepared, and also to Crystal, who stayed with and got this information out of Neil, Leo, and a few other experts at the end of the last session. And so that's what really got us, I think, moving forward for this presentation, because they had already hashed out some of the, what is it that people want to know and need to know. So thank you to Crystal as well. Please consider joining us in February for the follow-up, which should be on the problems and maybe other ways of using JSON. If you have not already, please notice that I sent out a new calendar invite with the updated invite information from Zoom. The fact that you are all here means that you found that. So if you know anyone who had trouble today or anything like that getting to the right place, make sure to have them look for the new invite and the new information for this calendar year.
I had Crystal.
Yeah, she told you?
Yeah, she was. She reminds me.
She's got your back.
She absolutely does. Thank you.
Thanks you all.
Excellent.
Until next time. Bye.
Okay.
Bye.